The objective of this project is to develop a smart recycling and incentive system or SRIS on campus to promote proper and sustainable recycling practice among students at university sites Malaysia. To achieve this, the system encourages active student participation by offering reward incentives while at the same time using technology to track and record recycling activity. Furthermore, the system helps monitor waste management performance, thereby supporting the university goals of becoming a greener and more environmentally sustainable campus. This project creates a positive sustainability impact in several important ways. Firstly, in terms of environmental impact, the system reduces the amount of recyclable waste sent to landfill by promoting proper waste separation and improving recycling efficiency through the use of smart bin and monitoring system. Secondly, regarding social and behavioral impact, the project increased recycling awareness and environmentally responsibility among students by encouraging active and consistent participation through reward incentive. Finally, from an institutional perspective, the system provides reliable recycling data to support effective waste management planning and at the same time strengthen University Science Malaysia's sustainability initiative and green campus image.
First, we identified 3 potential projects for University Science Malaysia. The first project is implementing a smart recycling and incentive system at USM. The second project focuses on installing refill stations to reduce plastic bottle usage on campus. The third project is developing the Think Green app for the USM community. All 3 projects aim to support sustainability, but we needed to select the most suitable one. Next, we compare the project using a checklist model. We look at several criteria such as the project objective, campus needs, target group, feasibility, budget, timeframe, risk, and sustainability. This helps us evaluate which project best meets USM current needs and can be implemented within a short period. After using the checklist model, we further compare the project using a multi-vector scoring model. We evaluate student engagement, feasibility, alignment with university goals, implementation cost, and sustainability with different weights for each criterion. Project 1, the Smart Recycling and Incentive System, achieved the highest score of 88.5, performing strongly in key areas. Project 2 scored 81.5, while Project 3 scored 73.5. Based on this result, Project 1 was selected as the most suitable project for USM. After comparison, we selected the Smart Recycling and Incentive System. Currently, recycling on campus has low student engagement. It is also not very attractive and lacks proper tracking and accountability. By using Smart Bin with an incentive-based tracking system, recycling becomes more interactive. Rewards motivate students to participate actively and consistently. The system also tracks recycling data, which helps improve waste planning and decision-making. Overall, this project aligns well with USM's sustainability goals and offers strong long-term values for the campus.
Next, I will present the WBS, which is called the work product structure for our project, the USM Smart Recycling and Incentive System. The WBS is a project management tool that breaks down the total project scope into smaller and manageable tasks. It helps team members understand what needs to be done, who is responsible, and how each task contributes to achieving the project objectives. Based on our WBS analysis, the SRIS project is divided into 6 key stages, which is project management, system design and development, procurement, installation and deployment, monitoring and evaluation, and project closure. At the start of the project, our team shared ideas aligned with USM sustainability and innovation goals. After evaluating several options, we selected the SRIS project. During our first meeting, we discussed the schedule, budget, and assigned role, which allowed us to prepare and submit our project management plan for approval. In the system design and development stage, team members designed the recycling system layout for key campus locations, including lecture halls, libraries, hostels, cafeterias, and academic buildings. At the same time, the software team developed a lightweight weight-based system where students can scan a QR code or the recycling links to earn reward points. Once the design was approved, we proceed to the procurement stage to acquire the necessary equipment. During the installation and deployment stage, our team inspected the site, installed the hardware, calibrated the sensor, and connected all components to the software system to ensure accurate data transfer. After installation, we conducted hardware, software, and integration testing to ensure the system functions reliably as a complete unit. In the monitoring and evaluation stage, we monitor system performance, resolve technical issues, and collected user feedback to continuously improve the system. Finally, the project moved into the closure stage.
Now, I will present the project schedule for the USN Smart Recycling and Incentive System, SRIS. The table below outlines all the key activities involved in the project. Each activity is listed with its code, description, and estimate duration in week. This activity range from initial planning and project approval to system integration and final project closure. Moving on to figure above, we have the activity on node diagram, which visually map out the logical sequence of this activity. This diagram helps us understand how each task connects to the next and where dependency lie. Based on the project network, we have identified one critical path for the whole project highlighted in the yellow, which is A, B, D, E, F, G, I, J, K, L, and M. The total completion time required for the project is expected to be 21 weeks. Any delay in this activity will affect the overall timeline. By carefully managing this path and ensuring timely execution of each activity, we can keep the project on track and meet our strategic goals for smart recycling and community incentives.
Good day. I want to talk about the risk management for our project. Please look at the first slide. This is our risk breakdown strategy. We use this chart to find all the possible problems. We divide the risks into four main groups. Technical risks include issues like hardware breaking or software bugs. Management risks focused on the schedule, such as project approval delay. Operational risks involve delay usage, like waste pollution. Finally, external risks are things we cannot control, such as supply chain delay or weather. Let's look at the risk matrices. This helps us see which risks are the most dangerous. For our project, time is very important. We have a strict deadline. Because of this, any risks that stopped our work is a big problem. You can see in the red box, our highest risk is the waste pollution. This happens if people throw food or trash into the recycling bins. We also worry about project approval delay because will slow down the whole schedule. However, baggage overruns are not a big problem for us because our cost is flexible. Finally, this is our risk plan. For every problem, we have a way to fix it. I will give you two examples. First, for project approval delays. To prevent this, we will prepare all our documents before week 1. If we are still late, our emergency plan is to shorten the set preparation time to catch up. Second, for waste pollution. To stop this, we will design the bin holes to be small. This stops people from putting the big trash inside. If the bin still gets dirty, our staff will clean it by hand. In conclusion, we are ready to handle these risks. Thank you.
The Smart Recycling and Incentive System, or SRIS, is expected to bring several key benefits to University Science Malaysia. First, it aims to increase recycling awareness and participation among both students and staff, especially in areas where recycling is often overlooked. By integrating QR codes and a reward system, SRIS motivates users to recycle consistently through incentives such as printing credits, USM merchandise, and cafe discounts. In addition, the placement of smart bins at strategic locations like libraries, hostels, and dining halls helps improve accessibility and convenience. This encourages positive recycling behavior and contributes to a cleaner and more sustainable campus environment.
In the long term, SRIS supports USM sustainability goals by promoting environmentally responsible habits and delivering measurable environmental and operational benefits. The evaluation plan for SRIS is structured based on the monitoring and evaluation framework shown in Appendix C, Table 7.1. First, system performance is evaluated by monitoring system uptime and technical issues using system logs and maintenance records. This ensures that the system operates reliably with minimal failures. Next, user participation is measured through the number of users and recycling frequency. Data from QR code scans and system usage records help determine whether participation is increasing and whether users are recycling regularly. For recycling impact, the amount of recyclables collected is analyzed using waste collection data. In addition, a before and after comparison is conducted to evaluate improvements in overall recycling rates after SRIS implementation. Finally, user satisfaction is assessed through such surveys to gather feedback on user experience, challenges, and overall satisfaction. Together, these evaluation methods ensure that SRIS delivers effective, measurable, and sustainable outcomes for the USM campus.
That's all from us. Thank you.